Hello guys, good morning, afternoon or evening. Welcome to our video. We are the group 5 or the Perpetual Motion Squad. This team is made up of
Edwin Briseño,
Luis Chanocua,
Josué Lozano,
David McDonald,
Mitzi Hernandez.
and today we're gonna present you the process of our work for the realization of this project during these weeks. The elaboration of this project consists of making a spaghetti bridge using our skills and applying the knowledge learned through this course in order to develop some skills that will allow us to perform as professionals in the future. Sin embargo, esto no fue una tarea sencilla, pues tuvimos varias restricciones y dificultades a lo largo de estas semanas. No solo las restricciones de construcción que nos indicaron los profesores, como las dimensiones y el peso que soportaría el puente, sino también problemas de comunicación debido al lenguaje, pues los estudiantes de México estamos aprendiendo inglés, así como los estudiantes de Estados Unidos están aprendiendo español. Otra de las dificultades fue que tuvimos que realizar una colaboración totalmente en línea, debido a la pandemia y por la distancia entre ambas escuelas. Sin embargo, supimos adaptarnos y lograr los objetivos que nos propusimos, no solo poniendo en práctica nuestro conocimiento de ingeniería, sino desarrollando nuevas relaciones. Por lo que con el fin de obtener los mejores resultados distribuimos las diferentes actividades que realizamos en una línea de tiempo y en un cronograma, para tener un mayor control del tiempo y cumplir con todas las actividades. During the first week, we carry out an investigation of different styles of bridges and the principle on which they were based, in order to have a clear vision of what we should do. In the following days, we acquire the necessary materials to carry out the design and simulation of some designs, to subsequently manufacture the prototypes.
With the prototypes created, we learned a lot from the mistakes we made while constructing them. We built two prototypes that were both based around traditional trestle bridge designs made out of X's and V's for the trusses themselves. The first one had a very flimsy design with us grouping spaghetti into packs of 3 for the beams. It weighed 2 pounds and could hold 4 pounds, which is double its own weight. We weren't satisfied with the stability, so we continued on to the second prototype. This one added a curved element with the trusses but still had a similar design. The main difference was the use of a packed spaghetti of 7 with rubber bands. This also weighed 2 pounds but held 6, so we're going in the right direction. We ultimately used the packs of spaghetti with rubber bands for our final design and learnt more about how to effectively attach the beams, since the prototypes didn't have the best attachments because we were getting used to working with spaghetti as a building material.
Las armaduras son extremadamente fuertes, son una opción rentable para la construcción de varias estructuras. Este modelo maximiza la eficiencia de la estructura. La estructura K es un diseño muy resistente porque sus miembros verticales están acortados, por lo que su resistencia es mayor. También es fácil de montar. Los nodos pueden tener menos compresión bajo la carga y también tienen menos tensión. Esto ayuda a tener un mejor uso con respecto al material que se ha utilizado. Este tipo de estructura puede soportar grandes cargas en comparación con otras. Las armaduras son sistemas livianos, pero con gran capacidad de soportar cargas. Brindan un mayor apoyo al plano del tablero del puente, ya sea en la parte superior de la armadura o en la inferior. Las armaduras en K también son estructuras muy estables por la distribución que llegan a tener en las cargas con respecto a sus nodos.
Bien, este fue nuestro dibujo donde mostramos el diseño de una armadura en forma de K, el cual se llevó a cabo en el programa MD Solix, donde podemos decir que este puente superó a los puentes que estábamos creando y fue el que convenció a nuestro equipo gracias a la profundización de la ciencia de su estudio. Nuestro diseño final podemos decir que fue una idea que surgió alrededor de todo nuestro equipo, ya que decidimos usar un diseño de una armadura en K, ya que cuando los dos primeros prototipos, viendo que no sostenían tanto peso como esperábamos, revisamos la idea de la armadura en K, la cual es más estable, con mayor capacidad para sostener cargas mayores. Esa finalmente fue la idea que se convirtió en nuestro puente final. Con este diseño final descubrimos que su nivel de eficiencia era lo suficientemente satisfactorio para todo el grupo. Con esto pudimos cumplir el objetivo principal que teníamos e incluso también logramos otro objetivo que teníamos, que era no dejar que nuestros prototipos se desperdiciaran. Sabíamos que el primer puente que construimos no iba a ser el mejor, pero en lugar de empezar de cero, decidimos usar lo que nos enseñaron los prototipos pasados para construir este nuevo puente, ya que, como se mencionó, entre algunas ventajas de la armadura en K es que tiene cierta reducción de comprensión en elementos verticales, mejora la calidad de la construcción y pues podríamos decir que hasta cierto punto su procedimiento de construcción fue simple.
The biggest shift we made was after we shifted from a standard trestle design in our prototypes to K trusses, which worked out well in our favor and continued onto our final design. Some of the pros of using this new design are that the points of compression are reduced, as well as having a simpler construction design with added stability.
Ya.
Hi everyone, I'm Edwin Briseño and I'm from the Perpetual Motion Squad, which is team number 5. And basically this is our bridge, and let's see how much weight it can support. Okay, so we have several weights. For example, this is this is 250 gramos. This is 500 gramos, and this is 1 kilogram. Okay, so let's see how much weight it can support the bridge. Let's start with 250 gramos, otros 250 gramos, 500 gramos, otros 500 gramos,
Ya, Beto.
estos son otros 500 gramos, estos son 250 gramos. Van 3 de 250, 750 más 1 kilo 500, 2. Le voy a poner el de 1 kilo para ver cuánto soporta. Otro kilo. Y ya voy a ver el otro kilo para ver si sí cala también. Entonces vendrían siendo 3, 4 y medio, 500, 200, 5 kilos, 250 gramos. 5 kilos, 250 gramos. Ya.
The most important part of getting this project right was teamwork. Our communication skills and the ability to work within our team creates such a difference in how effective our ideas are turned into physical builds. In order to have these proper team skills, we made it so that we have a group chat that we constantly communicate in so that we could discuss our ideas right on the spot. We also use Google services like Drive and Docs to create shared documents that we can all view and have input for. A big thing that I think worked for cementing our team's ability to work together was having some free time to know a little bit about ourselves. Having this friendly relationship with one another created an environment where we were open to share new ideas and made team meetings not feel like a chore. On top of the group chat, we also had weekly Zoom meetings to discuss verbally on how to implement our new ideas.
Intercultural knowledge. Having our group being split, some members attending Instituto Politécnico Nacional in Mexico and Florida International University in the United States creates an interesting work environment. Our two views were incredibly unique from one another. Differences with language we speak, where we go to study, to how we eat. We each had our own way of going through university differently from where we live. Our backgrounds had an influence on how we decided to approach our project as well. Group members from IPN suggested using designs with triangular shapes for the bridge design, in comparison to suggestions from the FIU side of the group, which involved more ideas using arcs. We discussed these ideas based on bridges we've seen around us, and these ideas are reflected on this. Global learning. As we concluded the design of our bridge, we went towards discussing the materials of the bridge. As the project gave us limitations of the scale, we had to ensure that the final product met the requirements listed. When we were discussing the building of the project, FIU students were more focused on the structure of the building as a whole, while IPN students focused on how different materials would be able to support more or less weight. We hadn't realized that our focuses were split when constructing our prototypes, so one of them was built without realizing how brittle our material was. It came crashing down. With some change in focus and focusing, we worked on our brittle materials such as raw spaghetti. We constructed a design that was better accommodated using the weak material. This change in perspective granted by some of our group members allowed us to work together and achieve something that was greater than the sum of our parts. Conclusion. Our journey in making this bridge was far from straightforward, but in the end we combined our skills learned from this course to reach our end goal. Working together to build a bridge, even if from different parts of the world, was our main objective. Moving through different designs and ideas, struggling with failure, were all parts that we were ready to learn as we worked together towards this project. Using the skills taught in the class through our lectures and videos, we used our critical thinking to best plan our project and how to move forward with each step. And the end results show our group effort towards this goal.